Alright, welcome back to the shop. Today I was looking at one or two parts of my steam locomotive that I want to build, which is a 5-inch gauge London North Western Railway Super D, or it's a G2. They were the last ones built of the 080 goods locomotives by London North Western Railway. I'll just show you some of the bits I've made. Let me grab out the camera, just go over and have a look. Here you can see some of the bits I've made. These are spring buckles here. They're for the tender. I've got to cut them. These are for the front 2 axles on the loco. That's for the middle axle on the loco. That's for the rear axle. I've got to turn that yet. So there's got to be a little stub shaft on each end. I've got various brake components I've made. These are the brake levers for the 2 vacuum cylinders on the locomotive. These are brake hangers for the tender. I've got to braze all these up. These are the materials here for them. These are brake rods. These are the horn guides. You see I've skinned one face off, did that yesterday. And these are the covers for the axle boxes for the tender horns. See them here? I've machined the back of them. I've got a whole host of other little bits I made here. And these are front angles for the buffer beam. But you can see I've got the drawings here. These drawings were done by a guy called Thompson, Nigel Thompson. I think these are available now from, can't think of the name of the company now. Anyway, not to worry. While I was machining these parts yesterday, see all that bronze there. We were working on the shaper, and whilst I was operating the shaper, I noticed the amount of play in the linkage mechanism here is starting to get quite excessive. I don't know if you can see that. The whole thing's starting to get clapped out, and I think it's time that we need to do something about that. It won't be long before we get something like a jam up or something like that and it smashes something. I don't want it to do that. These are some special material. You can't get them now, although I think there's people doing CNC reproductions of them, I don't know. But anyway, I don't want to see this thing smashed, so what I want to do is I'm going to take this off and we're going to try and reduce some of this clearance and get this running so it's quite smooth. But I'll just start it up and show you. If you put any resistance on that. You can see it kind of sort of kicks. It's not a smooth operation, so we need to do something about that. This is very sort of hit and miss as well. I need to do something with this mechanism here. You can see it's very sort of hit and miss. Not very impressed at all. So anyway, I'm going to start stripping that down. Right, I've done some repairs on the shaper. On the feed mechanism, you'll see here, we've made a new bush. We made a new pin or spindle to go in there. We made a new bush here to go in there. With a lot of play, I had to bore that out, 9/16, should be 1/2 inch, it's 9/16 now. We've done some work in here. I've had to refix the gear in here. Really interesting little locking arrangement for the gear onto the shaft. Not a strange affair, but I've fixed the gear onto the shaft now. It's pretty good, and it seems to be working quite well now. You're not seeing any movement, any clonking or banging or anything like that now. But you can see we're machining some components from the steam locomotive here. These are the horn guides for the tender. So these go either side of the axle box bearing for the axles. little shaper's doing a good job there. Quite pleased with that, but it's given me some quite good satisfaction seeing that all the play has now gone out of that mechanism. There's obviously enough play there to allow the system to function, else it would just jam up. But it's a lot better now than what it was. I'm quite pleased with that. Right, we're still machining these bronze horns. This is number 5. There's another one over there to do. But I just want to show you this. You can actually see the clapper working here. So what's happening on the return stroke is we're feeding across. So the tool then is dragging over the material and also over the swarf as well. So to allow that to happen, we have the pivot pin here, and it allows the clapper to clap like that, so you can see. What you don't want with a shaping machine is it running that fast, that thing's going up and down like this, clapping away there. That's not good. Nice steady speed, especially on bronze. Well, this is gunmetal. It's actually gunmetal, which is a form of bronze. You don't want to run fast. Nice steady little pace. Machine's stable, there's no shaking, no vibration. You know, it's not jumping around on the floor, it's not dancing or anything like that. A lot of inertia with the rams and shapers. Usually the bigger the stroke, the slower the RPMs, or the reduction in the number of strokes per minute that you want. When you've got very, very short strokes, you can run lots of strokes per minute, but you start getting big strokes. Imagine some of these big shapers, like these big Cincinnatis and Butler shapers, Ormerods and things like that. You get 36-inch stroke. You know, you wouldn't want one of them running at 150 strokes per minute. At that kind of stroke, but you think, I wouldn't want to be in the same building as it. But, you know, 11, 12 strokes per minute might be okay. That'd be quite a nice speed for it. But this is running nice now. We're doing about 5-inch stroke. You can tell normally just on here. So you can see the little gauge on the back here, on the side. We use that to set the stroke length. And we always set it when it gets to the back. So when the pointer's at its furthest travel at the rear, it's just shy of 5. You can also see all the lubricant on here as well, on the slideways. I've just oiled this today. I don't have to oil this very often because I've scraped all the ram and I've scraped the slides in here as well. We've got good lubricant retention now, and I like that. So it means we haven't got to keep lubricating it because it's actually staying in all the little pockets, which is what we want. And there you go, it's just finished its cut, so that's that one done. I'll take this one out, I'll put the last one in and do that. Right, this is the last face now. This is the last cut. Once we've machined this face, I'll probably do the opposite edge then. So we'll have a look at that. But there you go. It's working quite nicely. Really pleased with this feed mechanism now. That's great. Check it out there. No play in that at all. It's really nice. Always make sure you get your timing right as well. Make sure it feeds on the return stroke, not the forward stroke. Return stroke is the feed stroke. The forward stroke is a cutting stroke. Right, it's nearly finished now. A little bit more. There you are, it's done. last one done. Alright, today I'm cutting a special feature on the horns for the axle boxes on the tender for this locomotive, and there's a step. I've got to cut this down 1/16 of an inch, and I've got to leave a 3/32 step there. So it should end up like this. So you can see, can you see the step there? That goes up against the side of the frame then, where the cutout is for the axle box. So that's what we're doing. So we bring this down to about 65 on the dial. And I've got a mark here that tells you where we are, 65. That leaves it about 2 thou shy for a clean up pass, drawing the tool up when we're finished. So I'll just show you how it works. You see that's cutting quite nice there. This knife edge tool doesn't give as good a finish as what a round nose roughing tool does, and certainly on the gunmetal, if you've got a more negative rake, it seems to work better. Well, not a negative, but if you had a 0 rake, top rake on your tool. Right, let's be extremely observant now. I'm waiting for our little line to come around. Stop it before the line gets to the mark, and I'll feed it by hand up to the mark. Here we go. See how I'm feeding on the backstroke. There we go. See? And all we'll do is we feed it back. Yeah. Stop. And we'll put another, let's not knock the brush down. Put another 20 on. And we'll start it again. Alright, I've virtually finished the horns now. I've got them in matched pairs now. They'll be like that, and the axle box will slide up and down inside of them with the bore through for the bearing. You can see they're all finished now. Just got some cleaning up to do on the ends, and then of course what we've got to do is drill the holes for the rivets. And it says in the drawings to mark off from the frames, but it's looking at that's the only way you can do them properly. I've just been checking my rivet snaps and the clearance for this web here, and them 2 little fillets. So anyway, what I thought I would do, I'm going to have to modify the frames because I'm actually using the Etna, which is a precursor class locomotive. I'm using a lot of castings from this, so the castings from Hotspur, or the frames from Hotspur Designs, are slightly different from the Etna ones, So what I've got to do, these 7/8, you see the gap here, it's 7/8, whereas the Hotspur one, the gap is 3/4 of an inch. So I'll open them up. I'll do it on a milling machine probably. And then we can I'll drill the holes like it says here. Can you see there, it says 6 holes, 1/16 diameter from the frames. So we'll mark the frames out, drill all the holes, and we'll put the horns in place, and I'll make a spacer to keep them at the right distance, and then we'll spot through, and then we'll rivet them in place. But at the moment what I'm doing is I'm just looking at the axle boxes themselves. These will be the axle box bearings, and they all slide up and down in the horn guides, and I've cut them up, you've done. But there's a lot of draft on these castings. I don't know if you can see them. So to counter the draft, I'm doing 2 together. I'm clamping there and there. Otherwise it'd just be a mess. So I'm going to change that tool. I'm going to put a different tool in. And we're going to rough them out, make a general rectangle out of them, and then we can think about putting the slot in the side, which would be pretty straightforward. So we'll get on with that now then. I'll just show you the start of the cut here. You can see that there. I don't know if you can see the shape of the tool. It's flat at the front, so it's a 0 rake. And it's curved underneath. Reminds me of the let's have a look at our swan neck roughing tool. So you see how that's curved, like a parabola. Well, that's what we've done with that tool there. So you can see. Let's just have a look. There you go. It's cutting away nicely now. You can see it's giving a good finish as well. It's still working its way across on its first pass, but you can see the discrepancies in the surface there. You can see the shiny bits, which is the machine bits. Typical of cast surfaces, that is. Never ever get them perfect. If you want them more accurate than this, there are other casting processes, but you're looking at more expense. These are just conventional sand castings. Quite satisfactory for what we want. We can machine this exactly as it needs to be. Well, we're on the second pass now. I'm just sending it back the other way now. Possibly it could clean it all up in this next pass. We'll see. Because I've reversed it now, I've had to reverse this to the other side now, so that's 180 degrees out now. Can you see? If you watch, return stroke, it's feeding. There you are. We're set correct now. Alright, it's not quite cleaned it up on this pass. We can let this finish, and then we'll put another cut on and send it back the other way. And of course, we'll have to reverse this 180 degrees out, so it feeds at the correct time. You can see that's leaving a good finish, that is. That's that round nose tool. I just use that for roughing. The 0 top rake. Well, we started our third pass now. This should clean it up now, okay. All I've done is I've turned the handle in quarter of a turn. Quarter of a turn is 25 thousandths. Be good enough for roughing this out. You can see that's pretty good. I've reversed this as well. So I'm feeding 5 thousandths on every stroke. But that should clean that up nice now, and then we can start rotating it round and generate the rectangular block then. That's cutting nice though. Alright, it's nearly all the way across now. It's cleaned everything up by the looks of it. About another 3/8 to go. I'm quite happy with that. It's a good finish as well. Yeah, it's doing alright, that is. Alright, it's finished that pass now. You can see it's done a good job there. It's a nice finish on that. What we'll do, we'll take these two out now. I'll clean the burr off. And now we'll rotate one of them through 90 so that face is up against the fixed jaw. And then that'll give us a nice 90-degree angle on the next face. And then we'll do the same on that one. And we'll keep rotating it around till all four faces are done. And then we'll start looking at the feature here, which is the recess for where the horn guide goes. Right, alright, I've just flipped this particular bar around. And we've got a round rod in here. We're using that to compensate for the irregularities in that surface. That is the machine surface we've just done. And you can see that's flush up against the vice jaw. That's exactly what we want. And now we're just letting this take a pass across here. Alright, this is the last cut on the second face. You can see there we're going across. Quite nice. We've got quite a bit of material to move off this. We've got the overall depth here needs to be 7/8 of an inch. Now the width that way is 15/16, and the slot distance over the two faces in the slots here is 11/16. So we've got plenty of material to come off. Alright, we finished this face now. What I'm going to do is take this out and I'll put the other one, which is on the bench, I'll put that in the vise and I'll bring it to the same state as this one. So two faces will be done. And then what I'll do is I'll 180 that and do this bottom face here. And then I'll leave that face, which will be standing up, and these two faces will be, the bottom one and the top one now will be shaped. So we'll do that one after, but I'll put the other bar in and I'll do that second face. Alright, today I'm continuing with the machining of the axle boxes. This is the second block and it's the second face. And you can see we're still going strong there with the machine. It's doing alright and doing a nice job. Nice and steady, not going fast. With high-speed steel tools and with bronze, you don't want to go too fast at all. You take your time. If you're using carbide, it'll be a different story, but even so, bronze doesn't like to be machined too fast. Well, that's quite nice. That's the last cut now on that second face, block number 2. Once we've finished this, I'll take it out and clean it up. And I'm going to work on face number 3, which is the one underneath the block. Once we get them two faces, opposing faces done, we can finish the top face then. And this has to be finished at 7/8. And that way is 15/16. Well, the shaper's doing a good little job there. See our mechanism's still looking good. Pleased with that. Don't get it wobbling and clonking and banging or whatever. Nice and smooth. This tool's giving us a good finish as well. There you go. Right, this is the third face on block number 2. I've still got to do block number 1. All I've done is I've cleaned this block number 2 up, rotated it through 180, and I'm taking this next cut off, or first cut on this face. There you go. Doing a nice job there. Now we've got something sticking over each end, so we can put the micrometer on both ends. We can get it in, and we can measure the thickness. It's not absolutely critical, this, because these outside edges here are actually in fresh air. But it's nice to get them as close as possible. I'll just show you on the drawing the bit that we're doing. See, here we are. This is the component here, the axle box. But at the moment we're doing that 7/8 wide dimension there, which is the overall width. And the horn guide, which is there, fits in there on the other side as well. So that's what we're doing. Alright, this is the finishing pass with a bit of luck. 16 thousandths depth of cut. That should bring it to about 7/8 nominal. So hopefully this should be it. Now we can do the other block then. We'll check it with a micrometer and make sure it's okay. Well, let's see what it's like when it's finished. Right, I don't know if you can see that. 875. It's that 7/8 of an inch. That's good enough for me, that is. Alright, this is side number 3 on that first block that we did. We'll machine it to the same condition as the second one. Well, I'm going to finish this third face on the first block. We'll measure that with the micrometer when it's finished and see what it looks like. Hopefully that's it. A big spider down there on the floor. See it crawling along the bottom there. It's a male, that one. A house spider. Anyway, back to our block. So I'll look from the side. Right, that's it. Let's measure it and check. Right, this is the fourth side. We've got both blocks together. We'll machine them all as one. It's got to be 15/16 of an inch depth there to there. Shouldn't take too long to do this. Alright, we're cutting the fourth face now. This is the second cut, and I'm bringing the tool, or I'm bringing the work from the left to the right. So I'm reversing it. So obviously I've reversed the feed ratchet mechanism. See, it ratchets on the forward stroke and feeds on the back stroke. But there's one thing I forgot to do, which is important. But I'm not going to do anything about it until the cut's finished. Let's see if you can guess what it is. We'll just have a look. What's going on here? And you should be able to see what the error is that I've made. Let's see if you can work it out. Alright, I'm cutting the other way now. It's nearly finished. Just in case you're wondering, when I said last time what was wrong with the setup when I was cutting, when the feed rate was that way, now it's that way. When it's that way, that needs to be canted the other way so that it moves away from the work as it's traversing. That's correct for feeding that way, sorry. So you're relieving the tool tip as you're feeding. And it just claps, lifts up and just drags back. That's nearly finished this cut now. Should be one more cut after this one. Bring it to size, which will be 9375. So that's 0.9375 inch, 15/16. Or thereabouts. It's not critical, but we'll try and get it as close as possible. Almost there. Right, there we are. Right, let's check it. Alright, on the last pass with a bit of luck now. For an 18,000s cut on. See, I'm not going to correct that yet. If I move that, that needs to be, because I'm cutting both ways, I really want that so it's completely vertical. But I'm not going to do that at the moment, because if I do, I'll lose the position of my tool. I don't want to do that, so I'm not too worried about that. I'm going to leave it as it is for what it is. Once we finish this cut, we'll measure it and check, and then we'll think about cutting the slot. When this is finished, we'll do some dimensional checks on it. And if we need to make any corrections or whatever, we'll do them then. Hopefully it'll be okay. It's given us a good finish. You always get a good finish on gunmetal. It's a nice material to machine. And of course, gunmetal is a type of bronze. Used extensively in steam locomotive construction. Big advantage of it is that it doesn't leach the zinc out. Brassies and a lot of bronzes and things that contain zinc. With high pressure steam, high temperature steam, it leaches the zinc out. So that's why they don't use brass or ordinary bronze in the construction of things or parts on a locomotive that come in contact with steam. They're always gunmetal. Gunmetal's resistant to it. But anyway, also so gunmetal is easy to cast too. It's a nice material. It's a beautiful finish. Like I said, it seems to like that negative top rake as well. You can see it on the tool there. If you have a sharp tool, it doesn't seem to, if you have a positive rake on the top, it doesn't seem to like it too much. But that's quite nice. I'm happy with that. Alright, you get a good overview of the shaper working there. Nice, neat little machine. That's doing a good job. And it's nearly finished that last cut. A little bit to go, and we'll get it checked. Alright, we finished that 4 sides for the axle box block. You can see both of them are done now, and they'll fit in there. Right, what we've got to do now is we've got to cut the slot that these will run in. And according to the drawing, it's 11/16 wide and it's 3/32 deep. So it's, what is it now? Yeah, it's 11/16 wide. So that's 3/32 deep from each side. I'm not too concerned about a precision fit or anything like that. I need to make sure we've got some give in these axle boxes. I don't want them binding when they're moving. It's really important, that. So we're going to get ourselves a nice running fit. Now I'm just thinking about how I'm going to do these, and I'm considering doing it in the shaper, so cutting that slot on either side, do it in the shaper. I can do it easy in the milling machine, and that's a possibility. But I'm going to have a think about that and decide what I'm going to do.